So functions in Python are just like functions in any other programming language, as we just saw. There are two broad types of functions. We have built-in functions and user-defined functions. Built-in functions are inbuilt into Python and they are extremely useful, as we'll see a little later. User-defined functions, on the other hand, are defined by the programmer and they can be used for different purposes as compared to built-in functions. We'll see a few examples of each of them so that we have a better understanding of these concepts. So let's look at some very simple built-in functions at the outset. So we have a function called ABS, which basically returns the absolute value of a number. So if you have a value of minus 100 assigned to a variable num, and if you say ABS num, it basically returns a value of 100 to you. Now, absolute value, as some of you may know, is basically if I have a value of minus 3.2, we'll convert that into plus 3.2. Absolute value converts all negative numbers to positive numbers. And if you have a positive number, it will just return the same number. That's what an absolute value function in mathematics does, right? So now there is another function called all. This is sometimes very useful. So let's see what the description says. The all function returns true if all the elements in an iterable are true. Now, what does this iterable mean? Iterable basically refers to any data structure that we have on which we can iterate. So for example, take a list, right? Take a list. Imagine if I have these 4 elements in a list. I can iterate through this list. Iterate basically, think of it like this. Can you run a for loop by accessing each element one after the other? This is a list, right? This is a list. Such data structures are said to be iterable. Similarly, if you take a tuple, suppose if I have a tuple like this, right? Then this tuple is also this tuple is also iterable because I can access one item after the other iteratively, right? So anywhere I use the word iterable, it basically means a data structure whose elements I can iterate one after the other. Typically, I'm mostly referring to data structures like lists and tuples. Okay. Okay. So let's look at this example. So what is it saying? What does the function all do? The function all returns true if all the elements in an iterable. Easy way for you to remember is whenever you see the word iterable, read it as list or tuple or any other data structure or a set. Right? Think about it that way. That makes your understanding much more simpler. So if all the elements are true, it returns true. If any element is false, it returns false. So let's look at an example here. A bunch of examples here. Let's go one by one. Imagine if I have a list containing these elements 1, 2, 3, 4. And if I say print all of list. Now it returns true because all these elements are non-zero. Now let's look at a slightly different example. Imagine if I have a tuple here. This is not a list. This is a tuple, right? Imagine if I have a tuple here with 4 elements and if one element is 0, because 0 is treated to be false internally within Python, when I say print all of LST, or in this case it's a tuple, it basically returns false. Now what happens if I have an empty list? Now let's look at it here. So when I have an empty list, when I say all of list, it returns true. This is how the function all is defined. Now I could also have a list with one value being Boolean, which is false. These two are integer. These two are integer. This is Boolean, right? Now when I say all of list here, since I have one value which is equivalent to Boolean false, it returns false for me, right? Very simple function, nothing very fancy, very simple. Now let's look at another function called dir. This is very useful. Let me explain what it does, right? So for example, imagine if I create a list of numbers and assign this to a variable called numbers. Now numbers belong to the data type list, right? Now whenever I say print dir of numbers, what it returns to me is another list. This is a list of all the attributes and functions that I have for the list data type. Like for example, for list, you have these functions, right? You have append, clear, copy, sort, remove, pop, insert. We saw some of them when we studied list data structure. So the dir function tells me or returns me all the variables or all the attributes associated with the data type. So the data type of numbers is list. So it returns to me all the attributes, functions, and variables that are associated with the data type list. Okay. So here is another example. Diffmod is a function. All these are inbuilt functions, by the way, just to reiterate the point. So diffmod basically takes two numbers. So if you say diffmod 9, 2, what it returns to me is a tuple first. And how does the tuple look? So when I divide 9 by 2, 9 2 4s are 8, and I have a remainder of 1. So this is my remainder and this is my quotient, right? So when I use the function diffmod, what it returns to me, it returns me the quotient and the remainder when I divide the first number with the second number. Okay, that's what the function diffmod does. Now let's move on to another function called enumerate. So what enumerate does is as follows. Let's look at an example so that it becomes easier for us to understand. Imagine if I have a list of numbers like 10, 20, 30, 40 assigned to a variable called numbers. Now, if I write this for loop, let's understand this for loop a little. I am saying, see, where am I use enumerate here? I'm using enumerate here. So when I say enumerate numbers, what it returns to me is it takes this list called numbers and it returns to me a pair of values. The pair is such that the first value in the I have index and num, right? Enumerate returns to me pairs of numbers where it takes the first value and it also returns to me the index. So when I print this, let's look at it and see what it returns when I print it, right? So that it's easier for us to understand. So what it prints for me is enumerate basically enumerates in English. Enumerate in English basically means to list. So what it is doing is it's listing each of the numbers, and when it's listing, it's also returning to me the index, right? So if you want to list a bunch of numbers in any iterable data structure, it could be a list itself, or it could be a tuple, or it could be a set, right? And what it returns to me is it returns to me these pairs of numbers called index and the actual value itself. And this for the syntax, so this is what I get. So if I want to get both the index at which a value is stored, right, this is a very simple way to do it. But here there is a catch. If you look at the enumerate functions definitions, I need to enter an iterable, and my default start value is 0. If I change the default start value slightly, so let's look at it with an example, right? So if I say comma 5, let's run this example now. Now what happens? See, earlier I didn't give any value here. The default value it assumes is 0. So when I say enumerate numbers comma 5, it starts the first index at 5, right? Now if I change it, just to show it to you, if I change this to 10, right, and run this example, my first value starts at 10. Is this clear? This is a very, very simple idea. So enumerate is used to list enumerate in English simply means to list. So what enumerate does, it returns these pairs for you with index and the value itself, right? So the next very important functions are, so filter is a very, very useful function. Now to understand how filter exactly works, let's look at it from an example. So imagine if I write a function called find positive number, right? And if I input a value to it, it returns the same number, right? It returns the same number if that num, it returns num if num is greater than 0, or else it doesn't return anything, right? So this is important. So what it does is if you input a positive number, it returns the number, or else it returns nothing. Now let's look at it this way. Imagine, so you understood this function, right? Very simple function here. Now let's imagine that I'm creating a list. So when I say range -10 to +10, and when I'm trying to print this, what it creates is this. I'm creating a list of numbers in the range of -10 to +10. Okay, I have values from -10 to up to 9. Right? I have a list of numbers here in this range. So of course, all these are negative numbers, right? 0 is neither negative nor positive, and these are all positive numbers, right? Now, this is where the function filter is extremely useful. Let's look at what it does. Here I'm using the function filter. For the function filter, the first value I'm giving is a function. This is the name of a function. This is the name of a function. And this is a list, right? This list is nothing but, this numbers list is nothing but this list from -10 to +9, right? What about the name of the function? We just defined this function, which is find positive number, which returns the number if it is greater than 0, or else it doesn't return anything. Now look at the fun part here. So the filter has two variables, the name of the function that you want to apply to filter out the points or to filter out the data, and a list, right? Now what happens is when I apply the filter function, let's assume it returns me a list called positive number list, right? Now if I print the positive number list, this is what it returns to me. So what filter did internally was, for every number in this list, for every number in the number list, it applied this function. It simply applied this function, and wherever the function returned the value, it kept it in the new list. Wherever it didn't return, it just discarded it, right? So this is extremely useful. So this function is called filter because this function, if you have a larger list, let's say you have a list A, and you want to apply a function through which you want to filter out a bunch of points, right? If you want to filter out a bunch of points from your larger list and create a new list, filter is the function to use, as you just saw. Play with this example, and you could also change this function here so that you understand the function filter much better. It's used extensively in data science because you always want to operate on lists like this. You want to apply a function on a list. Of course, you would have done this without the filter function by using a for loop, but filter function makes the code much more elegant. Okay, so this is about simplicity of code. Of course, we can do it with a simple for loop without doubt, but this is more beautiful because the language provides it for us. Now there is a function called isInstance. So what isInstance does is, suppose imagine if I've created a variable called LST, which is a list of 1, 2, 3, 4. Now if I say print isInstance of the variable name, and this is the data type, right? So what it tells me, what I'm asking here is LST a variable of type list or not, for which it returns true. Now let's now create a tuple T. Say 1, 2, 3, 4, it's a tuple. Remember, this is a tuple, right? Now when I say isInstance T list, of course T is a tuple, not a list. So when I say this, it returns false. So isInstance is used to find out whether a variable belongs to a specific type of class or data type. Okay. Next comes a class of very, very useful and interesting data types. Not data types, inbuilt functions. Map. These are some of my favorite functions. You have functions like map and reduce, which are super useful. Let's look at these examples. I've used map, filter, and reduce a lot in data science, as you'll see later. The map function, again, is a very elegant function. So imagine, let's take a simple example. Imagine I have a list of numbers 1, 2, 3, 4. And imagine for each of these numbers, I want to compute the square of these numbers, right? So I want to finally get a list which is 1 square, which is 1, 2 square, which is 4, 3 square, which is 9, and 4 square, which is 16. Imagine this is what I want to do, right? How do I do it? I can create, this is the classical way of doing it. This is the old way of doing it, right? Without using our map function. Okay, what I would do, I create a new list called squared. For num in numbers, I just say square.append num power 2. So this double star it basically means num power 2. This is what it means, right? This is the old way. And then I say print square and I get the value. This is an old way of doing it. Is there a more elegant way? See, what am I doing here? I'm taking each element of the list and I'm using a for loop to achieve the task that I want to do. This is perfectly all right. But map makes it much more elegant and simple and without having to write the for loops. Now let's look at it. So I have the same function I have the same variable numbers. Here I'm defining a function. I'm defining a function called power of 2 that given a number, it returns the square of the number. So this function returns square of a number. It returns the square of a number. Now, without having to write the for loop, you can just compute your new variable called squared, which has the squares of all of these numbers using one line of code. This is the elegance of map. So it works like this. I say map. This is the function name. This is the function name that I want to apply to each of the values in this list. So here I have a list, right? So what I want to do here is I want to apply this function to each of the values in this list. And the output, I want to convert it back to a list. Right? This is very, very simple. The first thing is basically the function that I want to apply to each of the elements. I want to apply this function to each of the elements, in this list. And whatever it returns, that's what map does. What does filter do? Filter applies the same. Filter also behaves very similarly. It applies this function to each element in the list, and wherever it returns false, it just discards that element. So filter is in a way taking a subset of your list or any iterable element, iterable data structure, and creating a new list. Here it's applying this function to the list that you gave, and it's returning a new list. Right? Very, very useful. So you will use filter and map a lot. Similarly, there is a reduce function here. Right? Reduce is also very, very useful. So let's look at an example just to understand. Imagine I have a list of numbers 1, 2, 3, 4, and I want to find the product of all the elements in the list. How do I do it? I create a new variable called product, give it a value of 1, then use a simple for loop. I'm just using a simple for loop and I'm saying for number in list, product equals to product multiplied by number. And when I print product, I get 24, which is the product of all these numbers. This is a classical way of doing it without using reduce. Now let's see how to do the same thing while using reduce. Unfortunately, the reduce function used to be inbuilt in Python 2. In Python 3, it's not readily available, so you need to import it. It's available, so you can just import reduce using this. You can say from function tools, right? Func tools, import reduce. This will help you import this function. Okay. Now, the way I do it is this. I first define a function called multiply. Given two numbers, it will just return the multiplication output. Now, the reduce function works like this. You have the function name and you have a list. Now what it does is, so let's look at it. Okay. What it does is, it will first apply this function on consequent elements. It will first multiply these two. What does that return? That returns 2 now. Now on this 2, it will now apply it with this function. It will apply the function multiply with 3. What does that return? 6. Now it will apply this function multiply between 6 and 4. What does that return? 24. That's what it finally returns at the end of it. So unlike map, which operates on each element individually, remember map and filter apply the function on each element individually, right? But reduce operates differently. Reduce basically applies the function from one element to other element consecutively. Okay, so what it does is it applies a rolling computation. It applies something called a rolling computation. So we had these elements, right? So what does rolling computation mean? It first applies the multiplication operation between 1 and 2, that returns 2. Now instead of applying between 2 and 3, it does a rolling operation, which means it applies the multiplication operation or the function multiply between 2 and 3. that returns 6. Now instead of operating on 3 as a rolling computation, it operates on 6. And now when I multiply 6 and 4, I get 24. This is how rolling computation works. This is oftentimes very useful when you want to find sum of numbers in an array or product of numbers in an array or a list in this case, right? So this is what the reduce function does. Now, of all the functions that we saw here, filter, map, and reduce are the most used from a data science perspective. Okay, these are very, very important inbuilt functions for data science because these functions simply avoid the for loop. These functions simply avoid the for loop, especially in data science, where of course we can achieve what they're achieving using a for loop, but if we can avoid it, it will make life simpler and code more elegant. Okay, having said that, now let's go to some simple user-defined functions. These are very, very simple. Why do we write our own functions? Because whenever we want to reuse the function, whenever you see the elegance of functions are, suppose you write your function here. Okay, suppose you write your function here. Now if you have to call this function multiple times at multiple parts of your code, now instead of writing the same code again and again here, you're reusing the code. That's one of the most important reasons for defining your own functions. It makes code much more elegant, much more manageable, and it avoids retyping the same code again and again. Now let's come here. Okay, so imagine if I have a function called product of the numbers, right? So what it's doing, it's basically simply computing the product. Here I'm defining a function. We know how to define a function. So here product numbers is a user defined function. This is a user defined function. It's not inbuilt into Python. We are defining this function. And we can simply call this function, as you all know, we can simply call this function like this, right? Product of numbers, and I can give it 2 numbers. Very simple example. We all know this. Now let's use all the stuff that we know to create a very simple calculator. It's a very, very simple calculator. Okay, I'll just walk you through this code. It's a very, very simple example. So I'm creating a function called add, which adds numbers, multiply, subtract, and divide, right? Very, very simple. I'm creating 4 simple functions. Now I'm saying print these 4 values. Print select option, 1 for addition, 2 for subtraction, 3 for multiplication, 4 for division. And I'm using the input function here, which lets me input a number, right? So whatever input the user gives, whether it's 1, 2, 3, 4, I put in a variable called choice. Then I say input your number 1 and number 2, right? Now if choice equals to 1, what I'll do, I'll add these 2 numbers and print them. I'm using the add function here. If choice equals to 2, I subtract. If choice equals to 3, multiply. If choice equals to 4, divide. Otherwise, else I just say invalid choice. Very, very simple code. We can just run this right now. It's like straightforward. So if I say, let's say I want to do multiplication. Let's say my first number is 12.2, my second number is 2.3, right? So the multiplication of both these numbers is 28.06. Like you have 9995, but this is roughly equal to 28.06 because it's 99999 here, right? So very simple code. Here, the reason we wanted to show this code here is because we are using all the concepts we learned, a lot of concepts we learned here. So we are using the if else, we are getting input using the function input, and we are defining our own user defined functions, which are addition, multiplication, subtraction, division. Very, very simple example, nothing very fancy.